Right now, something is moving through our solar system. It's not from here. NASA tracked it. Scientists can't explain it, and it might be watching us. What you're about to see will change everything you thought you knew about our place in the universe.
We left off with a hanging question. What if it's not that simple? Look at these numbers. After Oumuamua, we started paying real attention. And you know what we found? More objects. Objects that shouldn't be there. 2I/Borisov shows up in 2019. It looks more normal, right? It has a coma, releases gas, behaves like an actual comet. Scientists breathe easier. Maybe Oumuamua was just a fluke. But wait. In 2023, something new arrives. An object some are still analyzing. And the patterns keep emerging. Small accelerations. Unusual reflectivity. Trajectories that make you wonder. Here's what nobody's talking about. We've only been looking for a few years. We've only found a handful of these interstellar visitors. But statistically, based on what we've detected, there should be thousands passing through our solar system right now. Thousands we can't see because they're too small, too dark, or moving on paths we're not monitoring. Think about that for a second. Thousands of objects from other star systems, drifting through our cosmic neighborhood, and we've only spotted 3 or 4 of them.
From beyond the stars it arrived, plunging steeply into our solar system. Skimming past the sun, its path bent only once, never to return. This is the hyperbolic.
Now let's talk about what happens next. NASA and other space agencies are building new detection systems. Better telescopes. Faster tracking algorithms. The Vera Rubin Observatory comes online soon, and it's going to change everything. It'll scan the entire visible sky every few nights, catching objects we would have missed before. When that happens, we'll have our answer. Either we'll find dozens of normal comets and asteroids from interstellar space, confirming the natural explanation, or we'll find more anomalies. More objects that don't fit. More mysteries that refuse simple solutions. But here's the really interesting part. Some scientists are already preparing for that second scenario. There's actual research happening right now on how to intercept one of these objects. How to send a probe fast enough to catch up with something moving at 30 kilometers per second. How to analyze it up close instead of watching it slip away. The European Space Agency studied a mission concept called Comet Interceptor. Japan's working on similar ideas. If another Oumuamua appears and we detect it early enough, we might actually be able to reach it. Imagine that moment. A spacecraft approaching an interstellar object, cameras focused, instruments ready. What would we see? Ancient ice from another stellar system? Exotic minerals we've never encountered? Or something else entirely? There's also this uncomfortable reality we need to address. The Great Filter. It's a concept in astrobiology that tries to explain the Fermi paradox. Why haven't we seen evidence of alien civilizations if the universe is so vast and old? Maybe intelligence is common, but something stops civilizations from spreading across the stars. Something filters them out. War. Environmental collapse. Technological self-destruction. And maybe these objects, these silent travelers, are all that remains. Evidence not of thriving alien empires, but of extinct ones. Or maybe we're completely wrong about all of it. Maybe these objects are perfectly natural, and we're seeing patterns where none exist. Our brains are wired to find meaning, to see design in randomness. It's kept us alive as a species, but it also makes us see faces in clouds and conspiracies in coincidence. The scientific method exists specifically to counter this tendency. Test. Verify. Replicate. Don't jump to conclusions. Don't let excitement override evidence. So where does that leave us? Right here. Waiting. Watching. Building better tools. Asking better questions. Whether these visitors are natural phenomena, ancient relics, or something else entirely, they're teaching us something fundamental about our place in the cosmos. We're not alone in the sense that matters most. We're part of a galactic ecosystem where matter flows between star systems, where objects from distant origins pass through our neighborhood, where the boundary between our solar system and interstellar space is more porous than we ever imagined. In a few years, we'll know more. In a decade, we might have definitive answers. Or we might have deeper mysteries. Either way, something is moving through our solar system right now. Something from somewhere else. And we're finally learning to see it. The question isn't whether more will come. They will. The question is what we'll do when we find them. There's something else. Something most documentaries won't mention because it sounds too much like conspiracy theory. But it's worth examining. In 2021, the Pentagon released a report on unidentified aerial phenomena. UAPs. They confirmed multiple incidents involving objects performing maneuvers that defy our understanding of physics. Instant acceleration. No visible propulsion. No heat signatures. Now, keep that in mind while we look at something else. 3 months after Oumuamua passed through our solar system, the US government quietly changed its policy on tracking interstellar objects. They reclassified certain telescope data, made it harder for civilian researchers to access real-time tracking information. Coincidence? Maybe. But when you start connecting dots, patterns emerge. Here's one nobody talks about. In 2019, a meteor entered Earth's atmosphere off the coast of Papua New Guinea. Scientists analyzed its trajectory and determined it came from outside our solar system. The first confirmed interstellar meteor to actually hit Earth. But here's where it gets weird. The US Space Command confirmed the interstellar origin, but they sat on that data for 3 years before releasing it. 3 years. Why? Dr. Avi Loeb, the Harvard astronomer who proposed the alien technology theory for Oumuamua, launched an expedition to find fragments of that meteor on the ocean floor. He claims his team recovered materials with isotopic ratios that don't match anything in our solar system. The scientific community hasn't fully verified his claims yet. Some are skeptical. Others say the data is compelling but needs more analysis. Either way, the fact remains, we have physical samples. Actual material from beyond our solar system, sitting in laboratories right now. And we're not hearing much about it. Let's talk about the timing again. Really think about this timeline. 1977, we launch Voyager. Our first serious attempt at interstellar communication. We put records on those probes with Earth's location, human DNA structure, mathematical constants. 1990s, our radio and television signals have been propagating outward for decades, creating a bubble of electromagnetic noise expanding at the speed of light. 2017, Oumuamua arrives. If you were an advanced civilization monitoring the galaxy for signs of emerging intelligence, how would you do it? You'd look for electromagnetic signatures, radio waves. And when you detected them, you'd send something to investigate. The travel time doesn't even rule this out. Oumuamua could have been launched thousands of years ago, cruising through interstellar space, waiting. Programmed to activate when it detected certain signals or entered certain regions. We assume alien probes would be actively transmitting, scanning, obvious. But what if stealth is the point? What if they're designed to observe without being detected? There's a researcher at MIT who ran simulations on this exact scenario. If you wanted to map the galaxy using self-replicating probes, how many would you need? How fast would they spread? His answer, surprisingly few. A few thousand probes, launched 1 million years ago, could have mapped every star system in the galaxy by now. The math works. The physics works. The only question is whether anyone actually did it. Now, let's address the elephant in the room. Why aren't governments more transparent about this? Maybe there's nothing to hide. Maybe it's all natural phenomena and bureaucratic caution. Or maybe there's a calculation happening behind closed doors. A risk assessment. If these objects are artificial, if they represent alien technology, what happens when you announce that to the world? Panic? Religious upheaval? Economic chaos? Stock markets crashing because investors realize humanity might not be the dominant intelligence we thought we were? There's a concept in government crisis management: controlled disclosure. You release information gradually, let people adjust, avoid shock. You don't announce "we found alien technology" on a Tuesday afternoon. You release reports about UAPs. You fund new telescope programs. You let scientists publish papers. You normalize the conversation slowly, over years, so that when the final confirmation comes, it's not a shock but a culmination. Is that what's happening? I don't know. Nobody outside classified briefings knows. But here's what we do know for certain. 1. More interstellar objects are coming. We're detecting them more frequently as our instruments improve. 2. Some of these objects exhibit characteristics we cannot fully explain with current natural models. 3. Multiple government agencies have acknowledged they're taking the possibility of non-human technology seriously enough to study it. 4. We're closer than ever to having the capability to intercept and study one of these objects directly. The next 5 to 10 years are going to be critical. The Vera Rubin Observatory starts full operations soon. The James Webb Space Telescope is already observing. New detection networks are coming online globally. We're about to have eyes on the sky like never before in human history. And when we do, we'll see more. More objects. More data. More answers, or more questions. Some astronomers think we'll detect 10 to 20 interstellar objects per year once our systems are fully operational. That's not a trickle of data. That's a flood. And here's the thing that keeps me up at night. What if they're not rare? What if Oumuamua wasn't unusual? What if objects like that pass through our solar system constantly, and we've just been blind to them until now? What if we're living in a galaxy crowded with the artifacts of other civilizations, and we're only just now developing the eyes to see them? Or worse, what if some of them are still active, still watching, and we've been observed for longer than we realize? There's one more thing worth mentioning. In early 2024, astronomers detected unusual signals from a star system 140 light-years away. The signals repeated on a precise schedule. Too precise to be natural pulsars. The story disappeared from mainstream news within weeks. Explained away as instrument error, natural stellar phenomena, nothing to see here. But the raw data is still available. And it's still unexplained. I'm not saying it's aliens. I'm saying we're living through a moment in history where the possibility has moved from science fiction to legitimate scientific inquiry. And whatever the truth is, we're going to find out soon. Because something is still out there. Multiple somethings. Moving through our solar system. Coming from places we've never been. And now we're finally learning to see them. The question is, what will we do when we truly understand what we're looking at? Part 4, the final question. So here we are. Standing at the edge of something profound. We've looked at the evidence. We've explored the theories. We've asked the uncomfortable questions that most people avoid. And now we're left with a choice. Do we look away? Pretend these objects are just cosmic coincidences? Go back to assuming we're alone in a dead universe? Or do we keep looking? Keep asking? Keep pushing for answers even when those answers might change everything we thought we knew? Because that's what this really comes down to. Not whether Oumuamua was a probe or a comet. Not whether 2I/Borisov was natural or artificial. Those are just the surface questions. The real question is deeper. Are we ready to know? Are we ready to discover we're not the first? Not the only? Not even particularly special in the cosmic scheme of things? Some civilizations might have risen and fallen while our planet was still molten rock. Others might be watching us right now, waiting to see if we make it past our own great filter, if we survive our technological adolescence without destroying ourselves. And maybe that's the test. Maybe these objects aren't just passing through randomly. Maybe they're measuring us. Our curiosity. Our scientific rigor. Our ability to handle uncomfortable truths without collapsing into fear or denial. If that's true, then how we respond matters. Not just as scientists or governments, but as a species. Do we approach the unknown with wonder or with weapons? With openness or with paranoia? The universe is sending us visitors. Silent travelers from distant origins. What we do with that information, how we interpret it, how we prepare for what comes next, that's on us. In the next few years, we'll detect more objects. We'll gather more data. We'll get closer to definitive answers. And when those answers come, they'll either confirm we're surrounded by natural phenomena we're only beginning to understand, or they'll confirm something far more profound. Either way, we're living through the moment when humanity transitions from wondering if we're alone to actively searching for the answer. From speculation to investigation. From hoping to knowing. And whatever we find out there in the darkness between stars, one thing is certain: we'll never see the universe the same way again. But this isn't the end of the story. It's just the beginning. Next time on Cosmic Enigma, we're diving into something even stranger. Something that makes Oumuamua look simple by comparison. We're talking about the signals. The transmissions coming from deep space that repeat on impossible schedules. Fast radio bursts that originate from galaxies billions of light years away. Patterns in the noise that shouldn't exist. And the question nobody wants to ask out loud: what if someone is trying to contact us, and we've been ignoring them? You won't want to miss this. Hit that subscribe button right now. Because when we release that video, you need to be there. This is the kind of information that doesn't stay available forever. Algorithms change. Videos get buried. But if you subscribe and turn on notifications, you'll be the first to know when we uncover the next piece of this cosmic puzzle. Drop a comment below. Tell me, do you think Oumuamua was natural or artificial? Are we alone, or are we being watched? I read every single comment, and your theories might make it into the next video. And if you found this investigation compelling, share it. Send it to that friend who's always talking about aliens. Post it in your Discord. Tweet it. Because the more people asking these questions, the harder it becomes to ignore the answers. We're building a community here. People who aren't satisfied with easy explanations. People who want to look deeper, think harder, question everything. That's what Cosmic Enigma is about. The universe is full of mysteries. Some of them are passing through our solar system right now. And we're going to find every single one. Subscribe. Comment. Share. And I'll see you in the next investigation. This is Cosmic Enigma, reminding you, the truth is out there. And we're going to find it.
And we're going to find every single one. This is Cosmic Enigma. Subscribe now, because the next discovery could change everything. Don't miss what we uncover.